welcome to another video. Let's walk through this physics question on the board. What mass of water at 25 degrees Celsius must be allowed to come to thermal equilibrium with a 1.85 kilogram cubed of aluminium, initially at 1.5 times 10 to the power of 2 degrees Celsius, to lower the temperature of the aluminium to 65 degrees Celsius? Assume any water turned to steam consequently recondenses. This is the case where we have what we call method of mixtures. Okay, when we have a hot substance transferred into a cold substance, and the mixture will be stirred thoroughly to aid even or equal temperature. Okay, to find out the equilibrium temperature, then a thermometer will be introduced so as to read and record the maximum steady temperature, also known as thermal temperature or equilibrium temperature. All right, so it means that we need to first understand that for a question like this, okay, heat will be lost by the hot substance and heat will be gained by the cold substance. So the hot substance in this case is aluminium, whose starting temperature was 1.5 times 10 to the power of 2 degrees Celsius. And this is exactly 150 degrees Celsius. So which means when it is transferred into water at 25 degrees Celsius, which is the initial temperature of water, okay, now the temperature will decrease. The temperature will fall, okay, because the water will absorb heat from the hot substance, while the aluminium will lose heat to the cold substance, which is the water. Okay, so then the mixture will be stirred using a stirrer, okay, so as to aid equal temperature or equilibrium temperature. So, and then when a thermometer is introduced, the maximum steady temperature, which is the temperature of the mixture, is 65 degrees Celsius. That is the temperature at which the heat lost by the hot substance is equal to the what? The heat gained by the cold substance. That is the temperature of the mixture. And that is the final steady temperature, or the, yes, final steady temperature. All right, so now, so in the question, we have that what mass of water at 25 degrees Celsius must be allowed to come to thermal equilibrium with 1.5 kilogram cube of aluminium. So which means we need to first write down the values we are given. We have mass of aluminium, okay? Mass of aluminium is equals to 1.85 kilogram, initially at 1.5 times 10 to the power of 2 degrees Celsius. So which means initial temperature of aluminium, which is the starting temperature of aluminium, initial temperature of aluminium, which is the starting temperature, okay, let me write that to be theta, okay, is equals to 1.5 times 10 raised to the power of 2, and this is equals to 150 degrees Celsius. Okay, to lower the temperature of the aluminium to 65 degrees Celsius, so we have the final temperature of mixture, which is theta subscript n. Temperature of mixture is 65 degrees Celsius. So it means that this is the final temperature of water. You know, when water absorbs heat from the hot aluminium cube, okay, then its temperature will rise, okay. So it's going to increase from 25 degrees Celsius to 65 degrees Celsius, because after the mixture is stirred thoroughly, okay, to aid even or equality temperature, okay, the thermometer introduced, okay, read and record the final temperature of the mixture to be 65 degrees Celsius. So this would now be the final temperature of water. Okay, now again, we want to calculate mass of water. Okay, so for water, we have mass of water. This is not given. Mass of water is not given. Okay, now we know that specific heat capacity of water, specific heat capacity of water, okay, is we can use 14186 joules per kilogram per Kelvin, or we can use 4200 joules per kilogram per Kelvin. Okay, so now we need the specific heat capacity of aluminium as well. For aluminium, specific heat capacity of aluminium, specific heat capacity of aluminium, that's Al, okay, C subscript Al is 900, yeah. That is 900 joules per kilogram per Kelvin or per degree Celsius. Okay, so now, so this is what we're looking for. What again? Okay, the initial temperature of water. The initial temperature of water. The initial temperature of water. This is given to be 25 degrees Celsius. So now, so it means that from what we have here, okay, I'm going to set up the equation, okay, for heat, okay. That is, we know that in this case, heat lost by hot aluminium cube is equals to the heat gained by water. So it means that we're going to have heat lost by hot body, which is the aluminium. This is equals to heat gained. This is equals to heat gained by cold body, which is water. Okay, so which means we know that formula for heat, quantity of heat, is Q equals to mc change in temperature. So which means heat lost is equals to heat gained. So for heat lost by hot aluminium cubed, okay, cubed of aluminium. So we have mass of aluminium multiplied by specific heat capacity of aluminium, then multiplied by temperature change, okay, change in temperature or temperature difference. Then we have mass of water multiplied by specific heat capacity of water, then multiplied by, now we have the final temperature of the mixture, which is temperature of the mixture minus initial temperature of water. So the initial temperature of water is, so theta I, initial temperature of water is 25 degrees Celsius. Okay, let's not forget that the starting temperature of aluminium is 150 degrees Celsius, because here we have 1.5 times 10 to the power of 2 degrees Celsius. So 1.5 multiplied by 100, that will be 150 degrees Celsius. Okay, and that's the first temperature of the hot substance. So, so from 150, the temperature drops to 65 degrees. So now, for mass of the aluminium, we have this to be 1.85. Then specific heat capacity of aluminium is this one will be 900. Then multiply by 150 minus 55. Okay, because the temperature in this case for aluminium will be 150 minus temperature of the mixture. So this will be equals to mass of water multiplied by 4200, then multiply by temperature of the mixture is 65, then minus 25, which is the initial temperature of water. Okay, so let me multiply 1.85 multiplied by 900, okay, multiply by 900, then multiply by 150 minus 65, okay, that will be 85. That will be 85. So that will be 141525. 141525. This will be equals to mass of water multiplied by 4,200 multiplied by 65 minus 25. That will be 40, which is 168,000. So now I can divide both sides by 168,000. 168,000. So that mass of water will be equals to 141,525 divided by 168,000. So this will be equals to 0.842 kilogram. So mass of water, okay, mass of water, okay, that must be allowed to come to thermal equilibrium with the cube of aluminium is, so mass of water is equals to 0.842 kilogram, and this is the answer to the question. The noblest pleasure.